Good morning, everyone. Perhaps let me begin by introducing myself. I think you've seen already in the program that my name is Tumisang Maphumulo. However, I'd like to urge you to not refer to me by that name because you may be surprised that I don't respond. The reason for that is I'm commonly known as Lebo Maphumulo. So for this workshop, please refer to me as Lebo. And what I can say for now is that I'm representing Eskom, and I'll be sharing information about high voltage power transmission lines. But before I actually introduce or welcome the panel to the stage, let me say a little bit about the topic that we'll be discussing in this session, which is basically water and energy. And we all know that these are scarce resources, and there's constantly work in place that tries to bring, the water and energy to everyone in the country. I'm fortunate to be the first speaker, which is always pleasant because the people haven't been blessed by much yet. You find them fresh after they've had their bacon and eggs, and they're ready to absorb. So, as I mentioned earlier, when I was asked to speak about connecting the communities, I said, the best topic that I can share is what I am competent at doing. So today I will be talking about high voltage, AC, overhead. Now each of these things actually refers to something. But as we go through the presentation, I will elaborate on what it actually refers to. And it's power transmission lines. So basically in this case, the product that is being generated or whatever is power. And our function as high voltage power line design engineers is to actually get this power from the generation sources. And as we all know, South Africa is a very unique network because our resources that are used to actually generate power are actually centralized. In other words, as we know, most of our power stations are actually in Mpumalanga, where we've got a lot of coal. And then, for example, if you're generating power via nuclear, you need seawater to actually cool the equipment. So what we're finding in South Africa is that our power stations are actually very local to some area, and then we need high voltage power lines to actually interconnect the load, which is basically the people that will be consuming the power, to the generating stations. I can't imagine you can see the legend properly there. But what is key to note about this slide is that if you look around the area that is in Mpumalanga, our dominating power generating means is actually thermal, right? I think everybody is very aware of this. So you will see this is kind of your space over there where your coal-fired power stations are generated. The minute you go to the outskirts, which is coastal, we've got our Kubek over there, but basically in Cape Town, that is the only power station that we have. So power transmission lines is actually referring to these blue lines that you see that are interconnecting the big towns in the country. Now let's go to the next slide, where all I'd like to iterate there is that, unlike I've had the privilege of being in Japan at some point, where their network is very unique also, because they actually have capacity to have power station scattered closer to the load in their country. In our country, we don't have this luxury. Therefore, we find that our network is dominated by long power transmission lines that actually need to be compensated. Now, when we talk about power lines, this line that says compensation is pretty much the same as any other form of compensation that you find in other spaces. And what you see here in this diagram, all these little blue icons there are referring to compensation devices, and those who are basically working in the power space would know that these are things like series capacitor banks. And if you find that it is at the station, it is normally your shunt compensation. We will not go into details of that because that is a topic on its own. Now, this next slide actually shows the future. What Eskom is in the process of doing is, designing and planning to build a super grid. Now, the super grid is something that we refer to as a backbone. What it does is it ensures that all the big areas or all the big load centers in South Africa are connected via some very solid lines that have high reliability. So in other words, if you see these lines that are shown in purple, or is it pink, these are 76 kV lines, and they are built with the highest level of reliability. In other words, they are very robust, and it is very rare that you would find that these lines are actually affected by things like birds, things like probably the environmental elements like lightning. Now, this slide right here is just to show for people that are interested in high voltage versus distribution. You will see there on the left corner that it shows the total length of line that we have in Eskom. And then it also shows the distance in terms of voltage levels. And as you can see, the backbone at the moment is only 2,600 kilometers long. And these are basically lines that are connecting Joburg and Mpumalanga to Cape Town. On the right here, I will not really elaborate on that because that becomes quite technical. But all it says there is, our network in terms of insulation is made up of 80% glass insulators and 20% composite. Those who have actually heard of this term composite will know that composite insulators were actually given birth to by trying to mitigate, performance issues on power transmission lines. Whenever you'd find that a line is traversing an area that is highly polluted or an area with dense mist or something to that effect, you would find that your glass and pin insulator was seeing a high number of faults. Now, with the composite insulator, they tend to be hydrophobic, so when pollution is actually building up on those insulators, when they get worked, the droplets tend to gather in clumps instead of creating a path for electricity to flow. And then at the bottom, I'm not going to talk about that because my presentation basically covers that. And then, of course, we are saying, I think this is something I need to mention about power lines. Most of us know that power station and substations are normally built in some location, right? The location is selected. You are able to actually gather information that is related to that area in terms of soil condition, weather, prevailing conditions in terms of pollution, rain rate, and that type of things. The thing that actually makes power lines very unique is the fact that they are long and they normally connect transfer power from one province to another, as an example, from Gauteng to Cape Town. So as a result, they actually traverse various environments. So you'd find that one power line is actually crossing an area where there's underground mining. Next minute, you are in an area where a farmer is growing sugarcane or maize. The next minute, you are traversing a township where there's a lot of houses that are being built there, and servitude becomes a challenge. So today's presentation is actually going to share innovations and some of the highlights that Eskom has come up with to actually try and tailor our designs to meet, the unique environment that the line traverses. And then at the bottom there, you will see that 95% of our maintenance is actually done live line. And live line is actually referring to the fact that there is no need to switch out the line when you need to replace an insulator or hardware is broken or anything of the like. When we do switch off the line, then we know that it is a very critical fault that has happened. But generically speaking, all our preventative and corrective maintenance is done live. Next slide just covers. Okay. So here, let's just touch a little bit about the line design cycle. And as we all know, before you put an asset in place, somebody might have to actually gather data to say there is a need for that asset to be built. And in our space, this is what we refer to as planning. So planners are engineers that actually forecast load for 20 years. They come to us, they say, we need a line from A to B. And then once that report is issued and approved, We have the second phase where land needs to be acquired. If you're going to build a line from Cape Town to Joburg, of course you'll need to acquire some servitude where you're going to put up the structures. And because land development matters actually happen over a long period, we parallel that with what we call the design. Now, EIA, some people might be wondering what that EIA stands for over there. It stands for Environmental Impact Assessment. And what we are basically saying there is, before we actually put up a power transmission line, the reason I want to elaborate on this is because whenever we are having a need to put up a line, we find that no landowner wants the power line in their backyard. We all want power, but nobody wants to be neighboring a power line. So how do we go about actually procuring servitude for this? So we actually have a full exercise that we do where we evaluate the impact that this power line will have on the community. Now, this impact looks at all impacts that are available, meaning your technical impact, your social, environmental, visual, economic. And by the time we actually put up a line, when you see our contractors busy building, for example, from Mpumalanga to Durban, you know that that route that has been selected is actually the one that's got the least impact on the people and the environment. Now, what is key to note here is that all of the skill Eskom has internally, so we do not outsource any of this. We are 100% competent to do this by ourselves. Then, of course, once you've designed something, there's manufacturing and construction, and this results from you obviously issuing a tender and appointing a contractor. Once the line is commissioned, then it is operated and maintained. So typically, all I can say is the life of a power line is actually 30 years, is projected to be 30 years, but we're finding that our power lines, even at 50 years, are still giving very good performance. This slide just says the line design, line engineering services and Eskom is actually a very powerful department that is capable of doing the full detailed design of power lines up to 765 kV in the AC space. This is something that we have done. It has been operating for over 15 years, so we are very much capable of doing this. When we talk about HVDC, of course, this is kind of a new area in the high voltage space. We are currently working on ways to actually go up to 800 kV. At the moment, we have a power line that's 533 kV, and it's called Kara Basa. It's actually connecting Zimbabwe with South Africa, and that line terminates at a HV station that we call Apollo. So at the moment, we are working on upping that 533 kV to 800, you know. Those of you who are maybe active in the electrical space will know that the reason that, you know, you find even internationally, people are always pushing to go higher voltage and higher is because the higher okay, firstly, the longer the distance, you know, the bigger the losses. So to mitigate losses on a power line, you actually need to go higher voltages, lower currents, therefore mitigating the power losses on that line. This just says we have over 31,000 kilometers of high voltage power transmission lines. Now, when we say high voltage, in Eskom space, we're generally talking about lines that are 220 kV and above. And when we talk about distribution, where we've got about 340,000 kilometers of line, we are talking anything that ranges between 132 and 11 kV. Now, of course, we all know if you're going to design something and actually put it out there to operate, you know, you need to perform tests on it. As an example, if you design a kettle and you say this kettle can boil water in 5 minutes, of course you'll have to do tests to ensure that this is indeed the case. Because when you design it, you are actually using theoretical knowledge to arrive to that conclusion. So Eskom is actually quite advanced because when we design these lines, and as you can see, we are currently busy with 8,000 kilometers of power lines that we are trying to put in place. These lines are at various stages. Some are at design, some are at tender stage, some are in construction, some are close to be commissioning, but this is basically the 10-year plan. So you can see how Eskom is working hard to actually get electricity to all the users across the country. Now, let's just show you guys, because I've got a slide here that talks about the phases that are involved in a high voltage power line. And I don't mean but you know, design of high voltage power lines is actually a very complex undertaking. And the reason I say that is because it actually involves almost all the disciplines that are available in the engineering space, right? So typically when we talk about conductors, that is an electrical aspect where we say, I need to transfer 600 megawatts from Joburg to Cape Town. What is the best optimal way that I can do this? And optimization, of course, covers a number of things, you know, one of the key being the cost, right? Of course, when you buy a car, you could buy a Range Rover, even an i10 would still get you to the location. But depending on what your client is actually targeting, you might see that in this design, reliability maybe is a priority. In another design, time to delivery is a priority. In another design, the client might specifically say, I need to do this, however, I don't have cost. I want the design to be safe, however, it must be the cheapest. So you will see that once the electrical engineers have selected a conductor, we have mechanical guys that say, this is a structure that you will need to support that conductor. And then we have civil guys that also help us with the civil foundations to get that power across. Now, I'm not going to talk, as much as I'm an electrical engineer by profession, I will not talk about electrical aspects of a power line because they tend to be very complex and sophisticated. And the reason I say this is because, think about it, we are constantly telling you that this silver structure is transferring power. However, you do not see the power, you cannot smell the power, you cannot touch it, you cannot feel it. You have to take my word for it that on those conductors, there is power that is flowing on that line. So electrical is quite intricate. I will not talk about it, but I would like to actually focus today's presentation on the mechanical aspects, because I say I need this conductor to carry this much power from A to B, but for me to actually get from A to B, I need something to support those conductors. And this is what this presentation is actually about. And the other reason that I choose to actually talk about mechanical is because these are visual things. When I show you the proposals or the innovations that Eskom has come up with to actually satisfy the client and the landowners, you will understand that, you know, getting power to the user is actually a priority within Eskom. So here I'm just saying, when we do our designs, before we even put them out there, we do actually test them. We've got 3 test facilities in Eskom, 2 owned by Eskom, the other one is NETFA. And basically what you see here is something that we use to ensure that when we build the line, it will not generate noise. I'm sure you guys have driven past high voltage power lines and you hear some sound that's kind of buzzing or hissing. You know, when you don't do your electrical aspects properly, you will find that you could end up building a line that's has a lot of interference on other infrastructure. So in other words, even people with TVs and telephone lines, you might see people saying, I'm not getting a signal. So this kind of test facility here is used to ensure that the spec that is put in place will perform accordingly. And as you might not know, Corona is actually very sensitive to prevailing conditions. So in other words, if I build a line that is at high altitudes, for example, in Nelspruit, where there's high altitudes, and I build a line in the coast, where obviously altitudes are low, the line that is actually built at the coast would perform better when it comes to generating noise. So this kind of cage here is used to verify our designs. What you see there on the left corner is what we call the tower test station, and this is where we actually test all our new designs. Here, this is what we call NETFA, and NETFA is actually used to do all our short circuit and high voltage tests. Now let's talk about some interesting project that Eskom is in the process of actually designing. So what we find in the engineering spaces, in the high voltage power construction space, is that there's very little skill in terms of, the different activities that occur when we build a power transmission line. So Eskom has actually taken it into their own hands to build a facility where, society is going to be trained. This kind of project is very beneficial to members of a society that are not necessarily skilled in any particular field. So when you come to a training center, you could be trained in a couple of things. It ranges from foundation to stringing conductor to tower assembly and erection. So this is something that Eskom is actually very looking forward to commissioning one day. And then let's go forward. Now, Eskom is constantly concerned with optimization and performance enhancement of the network. And this slide here just summarizes. It shows that, pre-95, these were the kind of structures that you would see on the road. If you drive from Mpumalanga to Joburg, there's a lot of these structures that you will see traversing the N4. After 95, we actually designed a structure that was referred to as a guide V. And as you can see, the cost saving over there was about 33%. The cost dropped to about 67%. And now in the late 95 and post, we have a structure that is called a cross rope. And as you can see, it is clear to see why the cost of this tower has dropped as much as 57%. The amount of steel that is used there is very much minimal compared to the self-standing towers. Now why is this slide not showing? Okay, let's just put it all up. So basically what this slide right here does is it summarizes the cost saving, throughout the cycle. So in other words, the material that you need to build the line and actually the construction costs. And all it does here is it gives information on what you call a suspension tower. So a suspension tower is something we use to just support the conductor. And then a strain tower is a structure that we use to actually change direction. Of course, if we're going from Joburg to something as far as Cape Town, there is no way you can do it in a straight line. So what this slide shows is just the difference between the towers that actually support the conductor in a straight line and the towers that actually deviate, change direction of the line. And as you can see, that cost saving there is quite substantial, right? So we are constantly trying to find means to provide power in a more competitive manner. Sometimes the way to actually achieve this is just by ensuring that you can push more power in the same corridor as a conventional line, and this will be very clear in the next slides that I will talk about. So going forward, I just want to talk about some of the highlights or innovations that are very commendable that our mechanical guys have actually achieved. And I will not really read anything on this slide because there's actually a slide that covers each of those innovations. So in our space, we are constantly having problems in terms of acquiring servitude. When I talk about servitude, it is basically the land or the space that we require to put up the lines, right? Again, like I said, we all want to have hot water in our showers, but nobody wants to have power lines in their backyard. So we're finding that, as time goes by, it's becoming more difficult to actually get the landowners to agree to sell us a portion of the land to build our lines. I mean, picture a landowner that's actually having a game farm on the property. Of course, having a structure like this in the property would not be something that is preferred. So what we've done here is, in areas where we find that it is difficult to acquire servitude, we've actually developed a structure that is capable of supporting 4 lines in one structure. This tower here uses the same servitude width, same footprint in terms of foundation. However, it is able to carry 4 circuits instead of 1 circuit in a conventional line. So we are finding that, the landowners are actually appreciating this kind of initiative because you only come to them once. Once they've given you this servitude, you will use, say, one circuit. After 3 years, you have another need. You're putting up a new mine. You're putting up a new development or a shopping center or whatever. And instead of actually procuring servitude next to each other, you will just build the line on that same circuit. So this tower right here is capable of actually supporting two 400 kV lines and two 132 kV lines. And there at the bottom, what you see there, that is actually the 132 structures, and here at the top, that's the 400 kV structures. Now, you guys, I understand from Godfrey that you guys had a tour of Cape Town. So as you know, Cape Town is a densely built-up area. And what happens is when we need to bring power into these areas, we normally find that there is no space. Even if the landowner wants to give you the space, we find that there's very little space because of the surrounding developments. So this tower right here, as you can see, is a very narrow tower in terms of its footprint, right? Instead of you having, well, foundations vary, but you can see why this tower would need half the size of the servitude of the other structure. So this tower here was actually designed to mitigate, built-up areas like Cape Town and Joburg. One of our proudest work recently was, in 2012, we tried to put up a line from I think it was from Majuba. Where's Majuba? But it was actually somewhere in KZN. It was spanning quite a long distance. And in Durban, you find that there's a lot of sugar cane farming, right? So previously, what we used to do is we would buy the servitude, and then the landowner would clear that servitude of sugar cane. No burning, no growing sugar cane in that servitude. But over time, they found that it was leading to big losses in terms of production and jobs. So what we've done is we've actually developed a tower where we do not interfere with the landowner's activities. So we've built these towers. Once we've erected them, the landowner can go on doing their sugarcane. When it comes to burning season, they still carry on burning the sugarcane as if there's no structures. So, this is really innovation at its best, And this tower is developed, as late as, I think the need for this tower was identified in 2012, and then the actual structures were actually designed and completed by 2014. So let's see what tower. Now, this is something that, a lot of South Africans would like to hear about because, as we all know, load shedding, right? This is an innovation that was developed as a means to reduce the disturbances, to the power users. So what this does right here is, as you can imagine, power transmission lines are very long, right? So it is physically not possible to actually build one line from some area to another without crossing over other existing power lines. It could be a railway line, it could be a power line, it could be a telephone line. But what we're saying is, in every design, it is literally impossible to actually eliminate crossing over other power lines. So what we've done here with this initiative is we are able to cross existing high voltage lines without switching the lines out. This initiative here is very powerful in the sense that we know that there's a constraint on our network, so actually getting outage. Outage is basically switching out the line that I'm crossing with the new line. Getting outage on lines is actually something close to being impossible. So this initiative here allows our contractors to build without okay. I think I'm at the end. It looks like I've exhausted my time. And here, micropiles is just a little mention about foundations. And we are finding that, to build capacity, we are needing to deliver projects quicker. And what the micropiles do is they actually cut the time that is taken to do foundations by up to half. They are more expensive, however, time is saved on the actual project delivery. Then I wanted to say today I shared a little bit of information about, mechanical designs, which are structures that enable us to go from one point to the next. If you are by any chance interested in learning about high voltage power lines, I promise you they are juicy. From the time I graduated, they grabbed my attention and they have not left my attention since. So if you find that maybe you work with substations and you'd be interested to know about the power lines, Eskom has actually put together a number of books that ensure that we do not lose skill, right? So when our young engineers come into the business, they're able to build competence very quickly via these books. So these books are actually available, and all they do is turn you into a high voltage power line design engineer. I think that is it for me. Thank you.